1 meter 100 centimeter, again 100 centimeter you can convert to millimeter. 100 multiplied by 1 centimeter, 10 millimeters, right? I hope you can be able to do that. Leave this 1 by some 10 lakhs. Leave it. No need to further simplify. Okay. Is it clear till now? RF factor. Okay. Now,
Yes, sir.
yeah. Now construction procedure. What is the first step? Do you remember? Already you have done one problem, right? What is the first step? Take this RF, multiply with the
Max length.
maximum length to get the
Maximum.
to get the length of the scale. So can you do that? Maximum length you can read from the problem. 200 kilometer. Okay. For example, if 200 kilometer is not given in the problem, but is asking to show the distance of 109 kilometer. So what is the assumption you can make? Suppose 200 kilometer is not given, maximum length is not given, but is asking to mark a distance of 109. Now, can you do some assumption here by yourself? 200 is not given. What is your assumption maximum length? Anybody in the class?
More than 156.
109.
More than 109. You can take 110, okay, or 120, because he's asking to mark 109, right? So you must take at least 109. Understood? Yes or no?
Yes, sir.
Yeah. Data
Yes, sir.
sometimes data may not be given. Some data may be missing. Okay, at the time, as engineers, okay, we need to assume appropriate data. Okay. Now here it is given, no issue. Now calculate length of the scale LOS equal to RF multiplied by maximum length. So again here you have to take care. Maximum length is given in kilometers, but length of the scale is always in centimeter because you are made after having centimeters, millimeters only. Okay. So 1 kilometer, 1,000 meter, 1 meter, 100 centimeter again. Okay. I think you can stop at centimeter because length of the scale is generally in centimeter. Okay. Now you got 20 centimeter. You calculate parallelly with me. If you are having mini drafter, calculator, drawing sheet fixed to the drawing board. Okay. If you are ready with me, okay, draw parallelly when I am teaching. Okay. Easily you can able to make up the one problem at least. That builds some confidence in you. Okay. Later, so many problems you can verify from the material. Okay. You can solve many number of problems. Okay. So what is the next step? Do you remember? Next step.
Draw
Calculation
20 centimeter scales.
20 centimeter length line, and you can take some width. How much width?
4 to 5.
Yeah, 4 to 5 centimeter. Doesn't have any meaning, but you can take 4 to 5 centimeter height. So how many number of parts I have to divide? That is important. Read the problem. What is the maximum length? What is the maximum
20.
length? Maximum length is given 200 kilometer. Okay. How many supposed to do? Yeah,
20.
20. Okay. Any other answer?
Or we can do 2 also.
Okay. 2 means each part will be 100 kilometers. Okay. Then how can you mark 109? Okay. You can think. There is no particular rule, okay, how many parts to be divided, but generally we go by maximum length to be measured. If it is less than 10 kilometer or 10 kilometer, we can directly divide 10 parts. But it is more than 10 kilometer. So if you take 200 parts, very Okay, very lengthy and
20
very
kilometer
very
1 centimeter.
very difficult to right.
So 20 kilometer equal to 1 centimeter.
No, no, you can't make such assumption now. What do you see? You need to divide the given length into number of equal parts. Each part should be some convenient length. That is important. Okay. That RF factor already we have taken. No need to take again to 1 kilometer 10 centimeter. Not like that. You cannot assume at this stage. That is given in the problem itself. We have already done that representative fraction. Okay. So any other idea? Anyone in the class? If you do 10 parts, what happens? Each part will be
20 kilometers.
each part will be
20 kilometers.
20
20
kilometers.
kilometers.
If you divide 5 parts,
40 kilometers.
40 kilometer. So we need to mark a distance of 109. Remember, keep this in mind. So which is convenient, we have to see. So diagonal scale, we need to first kilometer. Next subdivision will be
Hectometer.
hectometer. Next subdivision will be
Decameter.
decameter, right? So 10, 10, 10 is the relation. So accordingly, you have to see which is convenient. Okay. So some of you, your friend is telling 2 parts, right? That is the best way. That is the best way. So each part will be 100. So why we are taking 100 means again we can simply divide 100 into again 10 parts. Each will be 10 10. Okay, and again that 10 we can divide into further 10. So that is the absolutely perfect method. Okay, so and the 2 parts will be the optimum value you can divide. Okay, so is it clear why we are taking 2 parts?
Yes, sir.
Further you will understand why. If you take some other parts, you try by trial and error, you can find some difficulties. Okay, now let us take 2 parts. One numbering system, right, and line division method also, you need to draw 2 arcs, taking any angular line. Okay, last arc you need to join to the other end of the line. 20 centimeter you got, right? The length of the first line is baseline is 20 centimeter. Height you can take 4 to 5 centimeter, right? And uh, after dividing, numbering it as 0 starting from here, leaving first part, and you can mark 0 100 kilometer. Left hand side there is one more 100 kilometer, total 200 kilometers. Okay, so this 20 centimeter is representing 200 kilometers outside. Okay, now what is the diagonal scale principle? What is the next step we supposed to do? Here, from left hand side, one part is there. How many kilometers are there? It contains how many kilometers?
100.
100 kilometers. Very good. And the right hand side, there is 100 kilometer. So let us divide equal number of parts. Okay, how many number of equal parts we will do?
10.
10. Okay, 10 means each division will be again 10 kilometer, right? So yeah, 10, 10 kilometers. Now let us do like this. Okay. Now remember here, see any angular line we have taken, 10 equal arcs we have drawn, and the last arc I have to join to the 0 line. Okay, and match your mini drafter scale to this line. Okay, draw parallel lines to that line. So all lines are parallel to each other. Automatically the first part is divided into 10 equal parts. But don't draw vertical lines from there, but you need to use the principle of diagonal scale here. So what you will do is after 0 line, you would get one inclined line, right? One parallel line. From that point, you need to join to the main zero line. Okay, main part. Okay, down below this first box. Okay, you have to join. This is the first line we supposed to draw. Okay, and parallel to this, you set your mini drafter scale, and from remaining divisions. Okay, remaining divisions are there, right? You need to draw so many parallel lines. This is the diagonal principle actually. Okay, this is the diagonal principle. So we have joined diagonally. Okay, all these lines are diagonal lines. Now you can even number it from right to left. 0 here, right? 10 kilometer, 20, 30, 40, 50, 60, 70, 80, 90. Understood? These are, there are 10 divisions. Each division is equal to 10 kilometer. Total how many kilometer? 100.
100.
Very good. Now you understood up to this, right? So uh, thereafter, do you remember what is the next step? Recollect.
Decameter line.
Recollect. This height we have taken, right? Intentionally, we have taken 4 to 5 centimeter height. Okay, even though there is no importance given to that. Why we have taken this much height is to divide this into further number of equal parts. Because the main unit contains 100. The main part contains 100 kilometer. It's a single division, right? It's a big division, and that part we have subdivided. We have got 10 more subdivisions. Okay. Now each division will be 10 kilometer here. Okay, but I need to mark like 109, 1111 like that. Even I need further subdivision. Okay, so intentionally we have taken this 4 to 5 centimeter height. We need to subdivide it. How to subdivide it? How many number of parts? Each division here up to this. So main division is 100. Next subdivision is 10. Now again this subdivision 110 kilometer we need to divide further into 10 equal parts. Then each part will be how much?
1 kilometer.
1 kilometer. So easily you can understand. Again you can take left hand side. You can observe here there is an inclined line drawn. Okay. Don't confuse. Here initially we have done two parts with the line division method. At the top, we have divided this first part again 10 parts with the line division method. Okay, here now again we are doing the vertical height again 10 parts. Okay, so last arc we have to join to the height of this box. Okay, draw parallel lines to that. You would get again 10 equal divisions. From there you can draw horizontal lines like this. Horizontal lines like this. Earlier you see from here we have drawn diagonal lines, not vertical lines. These are the diagonal lines or inclined lines. Okay, but coming to the vertical height, we have divided again 10 parts. Each division will be 1 kilometer. So from down to top, you need to give the numbering system. 0 here, 1 kilometer, 2 kilometer, 3 kilometer, 4, 5, 6, 7, 8, 9, 10. Remember, we have drawn horizontal lines from 1 to 3 kilometers, like this. Now the construction is over. Now the question is how to mark a distance of 109 kilometer with the help of this scale. Okay. Any idea? Anybody can respond. No issue. 109. Okay.
Intersection of hectometer and decameter line.
Okay. Can you tell me where is I need to mark 109? That means 109. So where I have to mark, I need to locate two important points. The distance between the 2 points will be 109. In that way I am asking. Where is 100?
On the right side.
100 is here, right? 100 is here. That is the last. To the right hand side of 0, you have already 100. Just you draw one vertical line there. Okay, that is the first line, extension line. Now tell me, where is the ninth kilometer? Where is the ninth kilometer?
After 0, we have to go vertically upwards until the 9th kilometer.
Yeah, are you saying this line?
Sir,
Yes, sir.
So along this first diagonal line from 0, if you go up to which horizontal line?
that point.
Ninth. Yeah,
Ninth.
ninth. This is the ninth kilometer. Suppose if you mark here this point, this could be your final extension line. In between these two, you will get 109
109 kilometers.
kilometer. If it is 110, if it is 110, where you will stop? This is 100. This is along this line. You would have at this point 110. Yes or no?
Yes, sir.
Yes, sir.
So you can draw one vertical line here, and this could be 110. Like that. If it is 112, 112, how to locate?
We have to go.
Next vertical line, we should go 2 steps upward.
I think this is the second diagonal line,
Yes, sir.
and this is 1, 2. At this point,
Yes, sir.
yeah. Now you can refer my material, and you can solve so many other problems. Okay. Uh, so similar problems will be there. You can solve such problems that create some confidence in you. Okay. You can able to make up any problems. Okay. Only thing is, till now we have discussed the length problem. Okay. If even it is area problem, same procedure. You need not worry about area problems and volume problems. Where is the difference? Is area problem, the calculation part, if you go to represent,
RF root, square root will be there, sir.
yeah, in case of RF, you take simply square root of the same, okay, convert into millimeters or anything, mm square, kilometer square will be there, convert into same units, you will get some representative fraction. Everything is same, okay. So maximum length calculation is also same. And locating, dividing line division methods, okay, again subdivisions, everything is same. There is no difference you can find. So in my material given to you, see in Google Classroom, okay, there you will find some other problems. You can solve them, okay. And remember here the problem gives you understanding of kilometer, hectometer, and ecometer. But here there is no such relation is there here. See, to the right hand side of it is all kilometers, left hand side is also kilometers, vertical height is also kilometer. So it is single unit problem. Okay, there is no sub unit like kilometer, hectometer, and decometer, right? This problem is entirely different. Okay, we have not divided this first part according to the decameter or hectometer principle, because in the right hand side we are having only single part. It is containing uh, more than 1 kilometer. Okay, more than 1 kilometer. That's why this problem is special. Okay, so all units are only kilometers only. Right hand side of 0 kilometer, left hand side of 0 kilometer, vertical height also even kilometers only. Okay, you don't find any hectometer, decameter principle here. Okay, so you, even if it is there, you can also adopt the same procedure to solve the problem. Even you can apply this problem for yard, foot, inch, okay, or furlongs, miles, kilometers. Okay, go to the chart. You can try. Okay, you can try such problems. Okay, is it clear? Any doubts I can answer? Then we will see some other models. Anyone? Any questions from this topic?
No, sir.
Yeah. Now, say I am showing you some red point here. That means this is one point that is 100th kilometer, and along the first inclined line, go to up to 9th kilometer horizontal line, which will meet this first diagonal line. This first diagonal line somewhere here. That could be the next important point. The distance between these 2 points, you locate these 2 points, okay, and just note down with pencil, and you drop one vertical line here. Don't draw a slant line. Don't draw parallel line to this one. Okay, don't draw like that. Okay, simply draw from this point. After getting intersection of this inclined line and horizontal line, simply mark a point here and draw vertical line with the mini drafter perpendicular to the baseline. Okay, and you draw one more perpendicular here, or I call it as extension line. Join the distance between these two lines. You draw one horizontal line, that is the direct that we call as dimension line. Mark on it a distance of what is given in the problem. So what is the distance between those 2 points? 109. Okay, kilometer, right? 109 kilometer. In between A and B, you draw one extension lines, 2 extension lines. In between, put a dimension line on it. Dimension line should be 1 centimeter away from the main rectangular box. Okay, draw right on it 109 kilometer, the distance between these 2 red points. Okay, so in this way you can use this scale for measuring even up to 200 kilometers, any value in between 200 kilometers. Okay, any value in between 200 kilometers. Now let us see some other problems. Okay,
Sir,
yeah, can you ask any questions?
sir, if you divide it into 20 parts, each part will be 10 kilometers, na, sir.
Each part will be how much?
10 kilometers.
10 kilometers. Very
So
good.
when
Okay.
we take a hectometer scale, then we will get easily all measurements, na, sir. It will divide into, if we divide into 10 parts, it will be 1 kilometer each part.
Yeah, what you are saying is if you divide into 20, right? 20 parts.
Yes, sir.
So each part will be 10, right?
Yes, sir.
10 means, see, when you apply hectometer and decometer principle, my right
Sir,
hand side,
only hectometer, sir.
yeah, that's the problem. See, when I apply that hectometer decometer problem, one condition is there. The main unit, right hand side of 0 mark, okay, each part will be 1 kilometer only. Then only you can apply that principle. But you are doing 20 parts, right? 20 parts means each division to the right hand side of 0 mark, each division will be how much? 10, 10,
10
right?
kilometers.
That is not applicable. Okay, if you do 10, 10 parts, that hectometer principle will not apply. Each division must be only 1 kilometer. Then that particular kilometer again I need to go for even left hand side also, that must be only 1 kilometer. Then only uh, I can divide that 1 kilometer. Next 1 kilometer is equal to 10 decameters, right? 10 hectometers. In that way I can do. But what happens if you take 20 parts means right hand side of 0 mark or left hand side of 0 mark, you are getting total 10 parts, right hand side 9 parts, left hand side 1 part, right? All 9 parts to the right hand side of 0 mark, each division will be how much? Each division will be 10 10. So yeah, if it is 10 10, you cannot say that I am dividing that means you are dividing this 10 hectometer into number of parts. That is not so. Okay, each will be 1 kilometer only. So because our principle is 1 kilometer is equal to 10 hectometer, so that principle is valid if each division, main division will be 1 kilometer only. Okay, not 10-10. That cannot be applied here. But uh, you can choose 20 parts, no issue. But you cannot say that I am dividing according to that principle, 1 kilometer 10 hectometers. Okay, you can divide, no issue. But the distance between the 2 points, you are getting from this method, you are getting one distance, right? From this point to this point, you measure with ordinary scale. If you divide 20 parts, again you will get one answer, the distance between the 2 points. Measure with ordinary scale. If these two are correct, if these two are matching, then your procedure is accepted. Okay, nothing wrong. There is no strict rule. Okay,
Okay, sir.
but whenever you say 1 kilometer, I am dividing 10 hectometer, means all right hand side parts will be only 1 kilometer only. Okay, not 10-10, not 20-20, not like that. Okay.
Okay, sir.
Yeah. Now you try with by doing 20 parts. Okay. Uh, each part will be 10-10. Even first part you can divide into 10. Each part will be 1. Okay. Okay. And you don't do anything with the diagonal scale. So if you take 20 parts, no, you need not do anything with vertical height. So what is the use of this diagonal scale then? Okay. Such questions will come. Understood?
Yes, sir.
Understood, right? So if you divide 20 parts, each part right hand side 10-10, left hand side also 10-10. If you divide these 10-10 again, 10 kilometer again 10 parts, 1 kilometer already has come. Okay, so you need not do anything with the vertical height. Understood? So if you are not using this vertical height, then what is the use of this diagonal scale? That question will come. Okay, that means you are doing plane scale only, like that. Okay, is it clear?
Yes, sir.
Yeah. And one more problem it will come is, if you do like that, how can you mark 109 at that time? You can mark. There is a chance. Okay, there is a chance, but you are not using this vertical height. Okay. Yeah. So you try. There is no strict rule, but see how many parts we have divided initially to two parts for convenience only. Okay, there is no strict rule, but whether we can able to use this scale for marking 1012 or 112 or 109 or 120. Is it possible to measure any value between 200? Okay, within the range of 200. That is important. That we have to see. Yeah. So once again, what we will do now,